Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to take a look at Heron's formula for the area of a triangle. So let's go ahead and get started. Now, when you're dealing with an oblique triangle, so I'll try to draw one now. You have a side that's greater than 90 degrees, so that's ugly, but that's not going to work either. But when you have an oblique triangle like this, okay, that's better. And you can clearly see that you have a side that is greater than 90 degrees. There is a formula for finding the area that we haven't covered before, and it's called Heron's formula. And so essentially how it works is, you got a side A, a side B, and a side C. And the formula works something like this. You have to first find something called the semi-perimeter. And that is essentially where you take the perimeter and you divide it by 2. So the first thing you got to find out is S. We're going to call it S stands for semi-perimeter, and it's going to be as follows: A plus B plus C divided by 2. So this gives you half of the perimeter. And then you take this value S and you use it when you plug it into the actual equation for finding the area of a triangle that is, an oblique triangle. So to actually find the area, and this is kind of interesting, the area is going to be as follows. It's going to equal the square root of S, this is the semi-perimeter, times the quantity of S minus A, times the quantity of S minus B, times the quantity of S minus C. Like that. Let me close my parentheses like that. And so this is how you find the area of a triangle, assuming, of course, you know all three sides. And of course, you can find out the length of the other different sides by using, the law of cosine if necessary, or the law of sine, whatever's missing in terms of what you need to know. All right. Now that we know what the formula is, let's go through an actual example. So here you can see we have our three sides. A is 29.7, B is 42.3, and C is 38.4. We just plug in the information as appropriate. So first we try to figure out what S is. And so to do that, we just take S equals 29.7 plus 42.3 plus 38.4, like that. All this divided over 2. And you will learn that this is going to equal 55.2. Again, you can check that on your own calculator. Now that that's done, we're pretty much just about done here. This is not a deep video. We now need to find the area of the actual triangle, because we now know what our semi-perimeter is. And so to do that, we got area here equals, the square root of, this is going to be a long square root like that. So our semi-perimeter is 55.2 times the quantity of 55.2 minus 29.7 multiplied by the quantity of 55.2 minus the quantity of 42.3. And then I'm running out of space, so I'll put it right here below. Multiplied by the quantity of 55.2 minus 38.4. So if you multiply all these together, which you could do on your own time, but I believe we have the answer right here. I'll just show you the steps right here. If you take this right here, these values right here, you put them in, you'll get a final area of 552 square feet or square meters, whatever it's in. So 552, square meters, square feet, whatever the actual units were. I didn't specify that specifically. 552, excuse me, not 55.2, 552.31, sorry about that. And so that is pretty much how you do it. Not that deep, but this is a great tool whenever you have a problem that requires you to find the area of a triangle that is oblique. So let me kind of go back and wrap up what we talked about and conclude the video. So in this video, we talked about the use of Heron's formula to find the area of a triangle. And so the steps are really not that complicated. One thing you need to figure out first is the semi-perimeter, which is basically the perimeter divided by 2. And so that's what the S value is. And so after you have that, the actual equation to get the area is just the semi-perimeter multiplied by itself when you subtract the difference from the different sides of the triangle. It's right here at the bottom. And so then we went through an actual example here, and we got an answer of 55.231, 552.31, excuse me. So again, there's not a lot of complex stuff going on here. It's all about knowing when to add, subtract, multiply, whatever you're trying to do to get the appropriate answer for the particular problem. So I hope this video made sense for you and you were able to understand what was going on and what we talked about. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.